Good morning, everyone. How's everyone doing this morning? Let's see if I can change the exposure here. There we go. That's the one thing about Logitech webcams. You have to reset everything every time. Morning, Big Z. Morning, Franco. Got to clean up this absolute freaking mess here. Oh, how's it going, Johnny? I feel like I've talked to you not too long ago. How's everyone this fine morning? It's actually not a fine morning. It is rainy and I won't say cold, but definitely not warm. So it's not a ideal morning. I also realized I should fix my my parents' kettle. So that's what we're going to do today. Not make that video, but it's something that has to be done anyways, so we're doing it. Oh, is my audio working? It is. Everything is working. I'll put Johnny's case in view here so he can see it out in the wild. Stopped raining, and it'll be sunshine for the next 10 days. Oh, that's good. Look at you. And you start vacation. I'm glad. Just because I'm suffering doesn't mean you guys should be suffering, you know? I actually just woke up. I did not sleep well last night. So I slept in a little bit, and that's why I'm a minute or two late for the stream, because I had to do everything in like 10 minutes to get ready. All right, that there. These guys I'll put away after. 4 lazy weeks, then you start moving to your new house. Oh yeah. Are you boxing all your stuff yourself, or are you having a company do it? Because if you're doing it yourself, you're probably going to end up giving away or throwing away so much stuff instead of packing it. It's been sunny all day, and now it's just getting humid. Interesting. Okay, let me go get the kettle. Coffee tastes a little bit strong this morning. I don't know what happened. I'm trying to pour out all the water in the kettle. Oh yeah, it's raining now. So it's probably humid in here. Let's see, 68% humidity in the workshop. So it's one of these deals. But the thermal fuse in here keeps blowing, and it'll work for about a year, 6 months to a year, and then it blows. I don't know if you can hear that. Something is going on in there. Have to find the triangle driver that fits in there. Hired a company, their insurance only covers my crap if they pack it. Oh, okay. All right, let's see if this comes out. I've got Kendrick Lamar stuck in my head this morning. Won't go away. Do I have to take off these? I'm trying to show you what I'm doing here. So I took off 1, 2, 3 screws. I don't remember if I have to take these Phillips out. Let's see. 1, 2, Phillips 2. I've started. Started what? Oh, the kettle? Or the stream? How's it going, Franco? I'm gonna be really absent-minded this morning because of waking up late and the weather overall very rainy. Oh, your auto start can kick in. Ah, interesting. Did you go check out yesterday's stream? Did an impromptu stream. May have been a bit late for you though. Why won't this open this time? Maybe something melted. Okay. Oh. Yeah, something did melt. Well, we're not fixing this. It's not worth it for a commodity kettle. Let me just text my parents. All right, so yeah, no fixing this one. I have fixed it a couple times, but I think enough is enough at this point. Let's see, probably fixed it twice or 3 times. Oh yeah, fair enough. It wasn't really a good stream anyways. We just kind of did nothing. So I'm assuming this wire used to all be white. Oh look, this one melted too. So yeah, time for a new one. I assume this used to all be white. There's my thermal fuse install. And we'll just confirm that it is open. Multimeter. You guys don't really have the focus on here. Configure video. Well, you pop over on the second screen. Camera control. There we go, I can see it a little bit better. There's my thermal fuse. Okay, can you guys hear that? Maybe not. So that is closed. That is open. So yeah, thermal fuse, blue again. No bueno. Time for a new kettle. Yeah, this wire used to be white. It turned red, probably from the heat. So yeah, this thing is done for. I don't mind fixing things, but this thing just, enough's enough. I'll tell you what the rating is on that fuse. Looks like I fixed it twice. Alrighty, Johnny. So the rating is 192C. So that's what I got, and what came out of it originally, I believe, was this one. Same thing, 192C. So enough's enough. It's time for it to go. I mean, I don't think it's a pending house fire because like the metal's not discolored. Like, come on, get off there. I crimped this a lot tighter too. So like the metals are okay. It's just maybe the copper brittled. I don't really know. Off heat cycles, and then that's what stops it from. What's on here? Oh, is that another thermal fuse? Oh no, this is a resistor. I'll go watch in the kitchen instead. Make some lunch. Oh yeah. So yeah, essentially, enough is enough. It's time to put this thing out to pasture. I've fixed it a couple times, but I would like to see though what happened to this wire though. How come it's red now? Maybe it senses a bunch of overheating cycles. I don't know. How do I get this back in now? Get in there. Why am I having so much trouble with this? Get in there. So yeah, this was back up into a clip here. And this was folded over like this. It was definitely overheating. Come on, don't be like that. My God. What is going on today? Nothing is cooperating. Oh, I see a little bit of corrosion in there. Oh, that's interesting. Oh no, not buffering. Right there. You see the dust underneath there? There's some corrosion in here. So that might be the reason this heated up, but if it heated up, it would have heated on this side. Yeah, I don't know. Oh well, point is, it's dead, Jim. Let's get this guy under there. And then slide this mica underneath. Like so. There we go. And back on with the cover. Yeah, definitely some meltage here. She's dead, Jim. No more. Well, that is unfortunate. It says date code 1903. I don't know if this thing is from 2019. It's definitely not from 2003. Oh yeah, there's some discoloration here too. So I'm feeling like possibly what happened is the contact resistance kept getting worse and worse, creating heat in the system. Maybe we can look at this Intertech number. 4002-796. Although that won't tell us the manufacturer date of this specific one. All There we go. Well, she's dead. Oh well. There goes that. That is done. Where did I put the base? Oh, the base over here. So yeah, those contacts, they look okay. It is what it is, folks. Sometimes you can't save it. So now I have 3 thermal fuses. They were reserved for those exact repairs. Okay. Let's put this guy back in here. Now what do we do? Man, I'm so freaking tired. All right. Let me have a quick look around. We could do this. The Unity thermal imager. It is charged now. That invention failed. Are you behind the stream? I'm not quite sure what you mean. Let me see here. Needs a bit of modifying. I'm not going to modify stuff that could burn down my parents' house. All right, let me see if I can take a look at the number. 4002,796. Hey, Adam. I don't really know which one this goes into. Uh, 4002,796. Search. Zero items found. Uh-oh. That's not good. Just gonna make sure I read it right. I do have a little bit of dyslexia. $4,002,796. That's not good. Is there like a US? Oh, which set? You're trying to make a device to help you put on your socks. Your hip is really painful. Can't reach down. Got a hospital appointment tomorrow. Oh, I'm sorry to hear that. And what set you building, Adam? Well, Warrior H2 by Kada. This one? Look at that. H2 Hummer. Morning, Joseph. That looks like a pretty neat set. I should, here, let me show you what I've been working on. I haven't worked on it for a little bit, but while I was feeling burnt out, it was nice to put together. I just have a ton more. I just haven't touched it in a couple weeks. Ta-da! This thing is huge. It has like 3,000 something pieces. This is also a not Lego. This is a Lamborghini Cyan. This guy, Joseph? Like a wow stick? So, this kit is probably the most amount of pieces you can get for the least amount of price, but like the majority of those pieces are these little blue pins. They are everywhere. Absolutely everywhere. But it has a complete functioning gearbox. There's a little shifter for it there. And it's all-wheel drive. So there's, you can see all of the, it shifts all sorts of little things. Oh yeah, I don't actually, There's a whole, anyways, there's a whole bunch of stuff it shifts, moves these little heads around. I'm not done assembling it, so yeah, it's pretty insane. So yeah, there's a little shifter there. I don't know how it's gonna do. Oh, here, yeah, there's little shift arms over here. Got a freaking little bug in here. So this thing has been nuts. Oh. Pretty insane to put together. It's weird that's not secured. We got a little engine put together here. Looks good. But it's going to be absolutely giant when it's finished. See a little drive shaft in here. This shifts some gears. You've got oh yeah, this is where the shifter is. Oh yeah, because it's got paddle shift, I'm assuming. So yeah, you go like this. See that? Shifts gears, or you can go this way. The thing is freaking nuts. So this was like $100 Canadian. So think about 70 bucks American for like 3,000 whatever pieces, 3,000 and something pieces. It is an absolute monster to put together. Somebody at Lego took a lot of freaking time to put this together. 50 pounds. Holy crap. That is expensive, actually. 50 pounds. What's that in Canadian kopecks? Yes. I am. Yeah, I will at some point. I mean, I've been working on it. Hang on a sec, Joseph. I'll show you in a minute where I'm at. Let's see. Okay, yeah, 50 British pounds to Canadian dollars. Yeah, 86. That's kind of pricey. Oh, yeah, no, I gotcha. But look at this. 85 Canadian dollars for 3,696 pieces. It's insane. Oh, yeah. I'm well aware. But it seems like these kits that get popular, the price comes down quite a bit, which is neat. So actually, you got a good deal. This is 103.87 here. So you got a good deal for that. How many do you have, Adam, if you don't mind me asking? How many kits do you have in total? Oh, look at this. Do you want to buy an engine? A Kia car engine. RC Warrior H2. Oh, there we go. Oh my God, look at that. I can get it for 40 bucks. Oh, that's the welcome deal. That's not a real price. This is a real price here. But you have to pay VAT on top of this. too many that remain half assembled. So this won't be the landed price in the UK. You'll have to pay VAT on the way in. Let me see how much this is for not welcome deal. 47.73. So it's still cheaper than this for me. Okay, so all right, Franco, enjoy. So Joseph, if you're still here, let me show you where I'm at with my self-designed RC car. So obviously it needs a little bit of tinkering. This is from the Snowspeeder. So this is like just like a control arm setup. Yeah, so this is a failed print here. This part is kind of done. So this is a front or rear knuckle, haven't decided yet. It's got bearings in here, front and back. So this is very, very sturdy, but as you can see, I did split the print a little bit. Oh, gotcha, Adam. So it's got sunken nuts, and then you just bolt through here, and that holds together. There's another version of this, but yeah, the wheel hex is here, so you put the wheel on top there. There's going to be an axle bolt that goes through. My stuff is not accessible, so an axle bolt that goes through, and you put a nut to hold the wheel on. Here's a control arm. So the control arm gets trapped between these two halves here. So that goes in there, and it has motion. Oh, here's a new version. That's the new version of the knuckle. So yeah, you would take this apart and see there's nice circular holes. So you'd have to run the screw through first. So there's another control arm. Yeah. I mean, I'm way too ambitious when it comes to these things. This was another attempt at a control arm. Rebuilding the Tamiya 4x4 into a 6-wheel car. Very nice. So yeah, essentially, so you sink a bolt into there, and then you put that in there. Look at the fitment. Fitment is nice, and then you pop this guy in like that, and then you go through here with the tool, and you're able to bolt this to the control arm. So here was another control arm attempt. So obviously, like, this was too much. And then I wanted it to fit together modular. Yeah, PLA, because this is all, first of all, this is all prototype. So yeah, so this was supposed to be the plate where it mounts onto. The print broke, but that's okay because it's just prototype. But this play here was purposeful, so you can set caster. You can bias one arm to one side and one arm to the other side type thing. So this is all work in progress. And I've printed a wheel somewhere too to check the fit. So I think this is good. Like this works really well. But then my problem is the axle stub here doesn't have the correct angle for a drive shaft. So I have to redesign this axle stub. And like this was made very precise. Like look at the tolerances on this. And this is actually a spacer. Need to get that out somehow. This was all on my on my really shitty 3D printer, by the way. Now with the Voron, I'll be able to make these out of ABS and to tighter tolerances. But so that's a spacer that just goes between the bearings, right, like that. And everything is like really precise fit. It's got these lugs and these holes so that they align and they're strong together. And I think that was the issue with this one, is that there was a little bit more thickness in the spacer than I wanted, and it split the PLA. And yeah, because of this lip that retains the bearing, you have to print it this side. So this was my next attempt, and you can see where the support was holding it. So at some point I'm going to continue this, possibly. But I may just have to do like a little desktop size thing to start to like publish a design, because it's just it's a lot of work. You design these parts, and then if they don't fit, you print it again and redesign, and yeah. So that the idea was to be modular, so you can make a 4x4, a 6x6, a tank tread version, like whatever you want. That was the goal. Build a little rotating tool rest out of PLA. Yeah, very, very brittle. But there are strong PLAs. So it's not entirely true. Like this stuff is ST PLA. This one's already broken here, so I can show you. So this is like some weird hardened PLA. Like it's more hard, but therefore more brittle. You see, like it breaks, I don't know, it breaks like glass. It's like, see how it like just shatters? So this piece was already broken, so it doesn't really bother me to break it more. But you see how it just like tears layers? Like, it's so weird. I'm gonna chuck this in my recycle bin, because yeah, it's not useful anymore. I was planning on building this differential, but this was the wrong material. But there are strong PLAs. That's what I was getting at. Back on the lid. Yeah, prototypes for sure. And the cool thing is you don't need a fancy 3D printer anymore, because you can just send it out to PCBWay or similar to get stuff made these days. PLA, this stuff. So this stuff, PLA Pro, is a lot stronger than normal PLA. So you can make things pretty strong out of PLA. And then, of course, you've got PETG that you can print on pretty much any printer. Not any printer, but pretty much any printer. And then ABS when it gets a little bit more serious, when you get a printer with an enclosure and stuff. So yeah, there are like this stuff. Like this is PET G. And this is extremely strong. Like, I'd have no issues using this as a gear drive. This is super strong. This is, I think this was PET G. But like, look how thin the walls are. And the layer adhesion, yeah, this was printed on the Voron. So I think this is PET G. But like, it is pretty strong. Yeah, oh yeah, definitely. Look at the surface finish there. That's some PET G surface finish if I've ever seen it. Even like these really thin sections here. So you can make strong 3D prints with a regular 3D printer, but I mean, if it came down to it, if I really needed something strong, I'd send it to PCBWay and then have it made in sintered nylon or something. I mean, that's just the way to go. It's not even that expensive anymore. But yeah, you're right. I should be building a small RC car to get started because it's a lot simpler. The problem is my ambitions. Oh, this is that. That's that PLA. I can't break this one because it's for the Voron V0 video, as you can see. But I mean, this is tough as all boots. Like, oh, I can hear it just slowly cracking, but that takes a lot of force. So this is pretty strong. I wouldn't balk about using this structurally. So like I think an RC car can be printed out of this stuff and be pretty resilient. I think it'll depend more on the design at that point. I'm wondering how small I can get gears and stuff to make the differential in a RC car and stuff. What was I doing now? I got distracted. We went on a side quest there for the RC car. Oh boy. What is this? Oh, no. I could literally go shopping in my shelves right now. It would be cool to do RC car or robot out of car parts. Now that they're powering AC compressors, accessories with motors. Could be practical. Well, I'll tell you, you can find motors kind of everywhere. Oh, it's buried. Like window motors and stuff like that. Like you could. Oh, what am I clicking here? Printables. Yeah, cable organizer. I actually printed a cable organizer. Prusa meters every single month. Oh, I missed something. Not sure why this simple model got so popular. So, what's Prusa meters? Do you get filament? Is that what they give you? I want filament. I haven't even tried Prusament filament. Points to redeem in their store. Okay. Did you use those points to get your XL? I would love an XL. Actually, I don't know if I'd even need an XL. I want to build a Voron because it's cool. Not this year because of this frickin' thing. Cost me a fortune. You got filament instead. Gotcha. Yeah, the size doesn't bother me that much because, like, at the moment I've got at least 2 3D printers that are sitting around doing nothing. Oh, 3. So I need to make a shelf for the 3D printers, but that requires a lot of organization. Oh, I know what we can do today. This is what we're going to do. I know what we are doing. This. That is something I can get into. And if we have time, we can do this. Thank you, Franco. So these guys I picked up this is what we're going to do today. These are motor drivers. They are, let me see if I can read that for you. DRV 8833. That is totally something we can do. So I'm going to solder this together. I'm going to put it in a breadboard, and we're going to give it a shot. We're going to learn about it, and then we're going to make a video about it. And then we can talk about these guys after. These little gear motors. CNC router table. Long mill or at mill. Well, do you use your tools like CNC and whatever for work? Like side hustle? Or is it just for fun? Because definitely if you use it for work, it's going to pay itself off. Yeah, these things are absolutely tiny. That's because I spoke about this in a podcast. Professor Boots, YouTuber, he makes little tiny RC construction equipment, and he specs these kinds of motors and stuff, and I want to build my own. So these guys have a threaded shaft, so he uses this for like hydraulics, and then I've got these. Side hustle for sure. Cutting boards and signs. Oh yeah, thinness. Yeah, for sure. These guys too. These little tiny gear motors. They're not the smallest motors I have, actually. I think I have one more type of motor. Oh yeah, here we go. Even smaller. I've messed with these before. Look at that. So absolutely tiny. And they have a little planetary gearbox sitting on top. So we're probably going to use this one to demonstrate this board. And then we're going to use these eventually. So the deal is, Professor Boots, he designs little RC construction equipment, and he makes all the 3D prints available, but he doesn't make a BOM available, like BOM. So you don't know what screws you need, you don't know what electronics you need. But I do know that he uses these drivers, and I know he uses these motors, and these motors. But the rest is up to us. So that's why I'm going to see if I can make my own, figure out my own electronics. I might have to buy a set of like a screw kit because I don't know what kind of screws he uses, but that's why I need to 3D print it. Actually, nor has he released his pubs. I don't know what that. Thank you, Adam. I don't know what pubs means. Pubes? Oh, PCBs. Yeah, no, he hasn't done his PCBs either. So this is where I'm at so far. The mini excavator. Wait. Why did I print 2 of these? Am I an absolute moron? Oh, this one layer shifted. Okay, this one's a good one. So, yeah, I've been slowly 3D printing the parts. Yeah, maybe I should have used support. This looks ugly as sin underneath. I might just pull the stuff out. But look, when I was printing these little rollers, I was like, oh, I'm going to put a bunch on the plate. I didn't notice I put 2 overlapping. Whoops. Yeah, so these little guys. This is, yeah, this one of those motors goes in here. Essentially, I need to print a whole lot more. These are the idler wheels. But yeah, so these guys hold these motors. Oh my god, that's a tight fit. I don't know if I'll be able to get it out, but whatever. So yeah, this goes in like that. And that becomes one of the hydraulic stages. Oh, it's stuck. So yeah, I'm printing out. I had black on the Voron. So this is on the Voron. So this is untuned still. And it prints phenomenally. I do need to do some tuning on it. But it prints great. So yeah, I just have to be more organized and make a big list. And then I need to find an accent color. Actually, since you guys are here, you guys need to help me. So this is supposed to be, here, I'll show you what it looks like. Let's see, screen. Professor Boots mini excavator. Okay, so, oh look, he's got the whole kit for the skid steer, $100. Kits, workshop. Oh, you can do this one for free. Oh, nice. He should have a project section. All right, let me. Okay, you're saying yellow. Okay, so this is what I want to build. So the black parts are going to be black, but the what color should the yellow parts be? And before you tell me what color, you need to know that it has to be a color I have already. That's pet G. That's pet G. All right, so let me get out my colors. So I have irresponsibly bought a whole bunch of filament. Really shouldn't have, because it was on sale. All right, so I have white, purple, black. So white, purple, black. Before you judge, I have to bring out all the colors. Hang on. That's black. Oh shit, that's not good for a cardboard spool falling off my desk. I do have red. What's this? What color is this? Oh, that's white. Okay. Okay. Purple, red. I have a shit ton. Why do I have so much filament, guys? This is black again. My God, I have so much filament. Okay, dark gray. That's not black, so I got these colors. So purple, you're saying? That's why I bought the purple. I have pink. Oh my God. Silver. Oh, we have a spill. Hang on a second here, guys. This is chaos. Gonna clean up the spill. What's a little coffee knocked over? Try not to stab myself on the X-Acto knife that's just sitting there. So basically how we're going to do this is I'm going to show you what I have, and then you're going to say in the chat the colors that interest you, and when we're down to 4, I'll make a poll. Okay, pink, red. Oh my God, why do I have so much filament? Red. Pink. I have also green. And what else? What is this? Black. Okay. Okay, that is all the colors. All right. So all of these, oh God, you can't see it. Okay, so all these plus a green, you know what, I'll bring the green over. Give me a second. Because it's been sitting loaded in a 3D printer that hasn't run for a year. So it doesn't matter. I'm gonna cut it off. Okay. so here we go. So these are all your color choices. So we've got white, I've got lots of white and lots of black. So white, black, purple, silver, gray, pink, red, and green. So what colors are we feeling? Because I think a yellow or an orange would be ideal. I don't mind pink at all. People seem to be reticent for pink, but I don't know. I'm not. Okay, so we got pink and purple, definitely. What else? I guess black should be eliminated because black is the color of the accent pieces. Okay, so we got pink and purple still. Hold on a second. Vero, can you come down here a moment and I'll put you on the spot on camera?
Okay.
Not like on camera, but on audio, I guess. Okay, so you see that RC excavator there?
Yeah.
Okay, so the yellow pieces, I don't have yellow. So I just need you to pick one of these colors that you think should be at least a contestant. So I got white, dark gray, green, pink, red, purple, and silver.
And what is this for?
I'm going to be printing this RC, so I just need to know what color. So to replace the yellow there, because the yellow is beautiful there, but I'm not buying more, like obviously.
Yellow orange, right, you mean?
Yeah.
Okay. Just making sure I know what I'm talking about. What is this?
This is white,
Okay.
dark gray,
Okay.
silver,
Okay.
purple,
Yeah.
pink, red, green. The black bits in pink. No, I already started the black bits in black.
I would say purple.
Purple. Okay. So we've got pink and purple in the finals. Nobody said any other of these colors. So
Unless if you're going for more realistic than dark gray. But
dark. Okay, dark gray. I'll put dark gray in the running.
how different is dark gray from black?
Quite.
That would be my. If it's quite a bit different, then yes.
Yeah,
If not, then light gray.
It's quite different.
Okay.
So if you can see there in the light.
Okay. Yeah, I would say for more realistic, obviously, then go for dark gray.
Okay, so these three are in the running now.
Yeah.
Okay, thank you.
No problem.
The yellow bits in purple. Yeah, I'm not. So I've already started printing the black bits. So it's not, the black bits aren't going to change. They're going to be black. Because I'm not buying any more filament for this, essentially. Actually, that's stupid because I will need to buy one filament. I'll have to buy for the tracks. The tracks will have to be red because that's the only whatchamacallit color I have, flexible color. Okay, so red is eliminated and green is eliminated. Oh, Vero's already gone. I think you're behind. Okay, so white can go back. I've got a lot of white. The pink I got on sale, I think because most people who do 3D printing don't want pink. So black is also eliminated. Black and purple. Yeah, looks like purple. So if the short list is purple, gray, and pink, I'm going to do a poll. Okay, let's do the poll. Start a poll. What should the yellow of the excavator be replaced by? Dark gray, purple, pink, and I'll just add an option here. Silver. Start poll. All right, get your votes in. Sorry, Franco. Can you try watching it in lower quality? So I'll keep pink out because pink is in the running. Where's my red box? There you go. Red can go put away. So we've got purple, pink, gray. This can go back as well. Purple, 67% of the vote. I mean, I feel like it's going to be purple, folks. Let's see how many votes. Yeah, I think pretty much, I think Johnny Bergdahl picked pink, and then everyone else is purple. That's fine. I don't mind pink or purple. It's insane how much filament I have. 240p. Oh no. Okay, I get you. Oh, purple 50%. What do we have? Pink and purple are tied. Get your votes in, people. Okay, so while the vote happens, I'm gonna go make another coffee, and then I'll be back, and then we'll solder up the motor driver, and then we'll give it a shot, and then, yeah, so be right back. All right. So I'm back. Looks like purple is going to be winning. I mean, if you really want to, but... So I think we're going to end it there. I think it's pretty clear purple is the winner in this case. So thank you for all the participants. So that means I can get started on the other pieces. Just not now, because I think I might be recording a video here today. So don't want that to be going around in the background. All right, so let's get it. Oh, nice. There's a nice silk screen on the back here. Out 1, 2, 3, 4. This must be a dual. This must be a dual motor driver. DRV 8833. Okay, let's do some research. DRV 8833. Screen. That's not quite the same breakout board. But let's see. No, I don't want a video. I just want to read. Two digital inputs per H bridge, one for each half of the bridge. You can PWM one of the inputs to control motor speed. I guess that makes sense. Up to 10 volts. Okay, that's good. So we're basically just PWMing one of the outputs, essentially. So this is the Adafruit board. I don't know what ASBS means. All right, let's look for something else. There, that's the board we want. Okay, so L298N is the go-to, but that's way too big. They use bipolar junction transistors, makes them inefficient. Yeah, okay. Okay, yeah, DRV 8833. 2 NMOS H-bridge drivers. 2 DC brushed motors, a bipolar stepper motor, solenoids, other inductive loads. That's good. There's not a lot of components on the board either, which is nice. Here, I'll zoom in for poor Franco, who was at 240p. Peak currents of 2 amps per channel. Okay, that's good. Under voltage lockout, over current and over temperature protection. Disable the H bridge. Low power sleep mode. Interesting. Okay, so this is nice. Sleep, out 1, out 2, out 3, out 4. Fault, I guess that's reporting a fault. Then you've got from the opposite direction, in 1 into VCC ground, in 3 and 4. Okay, power pins, it's good. Voltage is as low as 2.7 volts, means perfect for low voltage projects. Yeah. Output pins. Yeah, okay. Motor A should be connected to out 1 and 2, while B should be out 3. Yeah, that's good. I think the dude was saying that ESP32 was starting to run out of pins for controlling these things. So oh, that's another thing we can do. Oh, where did they go? These I'm gonna put away, but I have a port expander, bunch of port expander chips to play with too. All right, in 4, in 3, in 2, and 1. This is going to be good. Forward, reverse, motor off, yeah. Control inputs are pulled low internally. Okay, that's good. Sleep, labeled EEP, controls the DRV 8833 sleep mode. H bridges are disabled. The gate drive charge pump. Ah, there's a charge pump. All internal logic is reset. There's a solder jumper J1. Keeping the DRV enabled. However, if you open J1, the onboard pull-up gets disconnected. This enables the on-chip pull-down, which means it'll stay disabled by default. Okay. Interesting. The fault, labeled ULT, is an open drain output that is driven low by the chip whenever an overcurrent, overtemperature, or under voltage occurs. You need to connect an external pull-up resistor. Yeah, it's good. The DRV 8833 can actively limit current between ASEN pin and ground. Set the limit for the motor A. Another BI-SEN pin to ground for B. Connects these current sense pins directly to ground, disabling. Okay, that's okay. So I guess it's not too bad. Should be able to easily deal with this. The inputs are all on one side and the outputs are all on one side. Should be fairly easy. All right, so let's start soldering. I can drive this with my little logic driver. 4G mobile signal to USB converter box. Is wired internet just way too expensive? Is that the deal? Also, what are the specs of the computer you're watching on? Because I do know that YouTube now is very hard to run on old hardware, and there's a way to change it. Go to YouTube and you select a video. There's a way to change the encoder, I thought. No. I don't remember how, but there is a way. There is a way to change the encoder. I don't quite remember how, because I think it uses AV1 now by default. And you can force it to use the old style. Maybe it's in your browser. But yeah, it uses less processing power. All right, back to the webcam. Let's grab a breadboard so we can properly do this. Let's see. I'll look into it after the stream, Franco. Because I do remember seeing that the new encoder was more efficient for YouTube, but required more processing power from the clients, from us. And so, if you can switch it back, it would be more betterer. Oh, what the heck is in here? Oh. I guess I threw a lot of the stuff that was on my desk into a box. Huh. So probably some of the stuff I was looking for is in this box. Oh yeah. So look at that. I was looking everywhere for that. Well, that's embarrassing. Threw everything into here. Oh, is that... I don't know if those QRs do anything. All right, get these guys stacked up. Older computer, definitely not a gaming machine. Yeah. There we go. I do have some British credit on Amazon. Try to send you a better machine. I need more British credit though. I need more British people to use my affiliate links. The way it works for Europeans, actually anybody who's not Canadian, essentially, or American, if they use my affiliate links on Amazon, I get an Amazon gift card when the total goes up over $10. And I had not put my info in, like my payment details in for like 2 years or 3 years. And then when I did put my payment info in, I actually got some British credit. And it's like 60 pounds or something. And then my plan was to convert that into gift cards and then do giveaways. But that didn't happen. And the reason is you can't use gift credit to buy gift cards on Amazon, which is stupid, even though they're Amazon gift cards. Yeah, I know you don't deal with Amazon. But like the credit is there. That's the thing. Literally to tell you the level of waste, because now that I cashed it in, I can't use it, like unless I can only buy product with it. So the thing I was thinking was to buy like steak and kidney pies and have them shipped over here. But it's stupid because the price of them way more expensive than buying it in store, and I'd have to pay £30, so half of my balance for the shipping. So that's quite wasteful. So I have a plan for next time I get one of those gift card codes, but now that I've cashed this one, it's problematic. So yeah, I have 63 pounds in British Amazon. So like if I can get you, like this needs to cool anyways, but here's the idea. Let's go to screen. You know, it's a bit more, but like something more modern like this would likely be better on the decode side, you know? Like obviously I only have 60 some pounds, right? But I mean, it's close. I'm getting there. Adam, I think I can. I haven't had a look since. But yeah, please do update your wish list, because that is an option. The thing is, I was considering all my options, and then I was burnt out, so I stopped thinking about YouTube stuff altogether. But yeah. So yeah, please do go and update your wish list. I mean, there's got to be something. Free UK delivery. And dismiss. Sort by low to high. There's loads on your wish list? Okay. Well, last time I checked, there was only a few things. Oh, look, this is not a very good PC. But I mean, we're getting close to the 60 pound mark. You know? I'll have to check my emails. Can you, Adam, can you send the wish list to not my Gmail account? It's a pain in the ass to log into the a web server email. You know what? Screw it. I'll do it anyways. I'll do it. Don't worry about it. I got you. You did send it to me once, so no worries. Shove loads of spaces into it. Okay. I have to have DVD, RW, and floppy drive on my PC. I do some... Yeah, but you can USB those. It doesn't have to be like USB DVD drive. See, USB floppy. See, you can have all that USB. USB connected DVD and floppy drives, yeah. Yes, sir. But anyways, that was just my, my thoughts, my train of thought. Back to the webcam. Should be able to plug stuff into here now. Probably going to be easier if I open up another one to have a look at the pins. Point is, I would love to give back to my viewers, and I thought that's what I was going to do, but Amazon had other plans, essentially. Okay, so this is backwards, right? It would be this way. But out 1 and 2 are up here. We're going to use for this. Don't have these connected to pins though. So maybe I'll solder it onto some pin headers. Pin headers. If I were a pin header, where would I be? This is coming to the organizational point of the stream. Oh, there we go. If you ever dig up the specs of your PC, let us know, because maybe, I don't know, maybe I can find a shop in the UK willing to hook you up in exchange for something I can do. Maybe a used PC, you know, with much better stats. You know, just I'd love to give back to my regulars. I guess that's what it comes down to. I would be honored if I could give back to my regulars, especially like affiliate income is really not moving the needle for me. It's like, you know, that 60 pounds was over the course of so many years, and they're pounds. Like, what am I going to do with them? Maybe I should pre-tin this. Spectrum ZX80 both have SD cards. You know what, the whole retro computing thing, I definitely know it's not for me. I would much rather emulate retro stuff. Just found your book on my list. Don't know what that means. Okay, so that's hooked up. We'll need a flag on this, but that's neither here nor there. So we need some wire hooked up there. Yeah, so need some wire to hook up to my little my little input box. Oh, we're also going to need power and ground. Wait, wasn't? I need 6 pins here, not 4. So I need power, ground, and then the 2 inputs. Or I could just split this in 2 and then use the breadboard. I think that's what I'll do because I'm lazy. Need something to grab. Do I say screw it and just use jumpers? Probably should just use jumpers. All right. So let's. Well, I'm gonna do this up here. It's probably gonna be easier for you guys to see. And then I'll have to make a little. Spectrum also has Wi-Fi and Bluetooth. Went a bit overboard. Okay, what am I doing? Oh yeah, let me go get my input box, which will be all dusty. Probably. It does not seem to be where I have left it. That is a touch problematic. Where could I have put it? Now what? It's a pretty freaking big device. I seem to have lost... Oh no, there it is. Oh, it was down here the whole time. You crazy mofo. This guy. I need to remake this at some point to be more friendly, you know? All right, so we need to connect stuff. Okay, these four, we only need 2 channels. So out 1 and 2, and we need VCC and ground from here. Oh, but I don't, oh my God, I don't have like pin header things. Let's see. So here's 2 wires we can use for the in. In 1 and 2 will be here. In 1 and in 2. In too deep, and I'm trying to keep something in my head. I don't know how that song goes. It's been a couple of years since I've heard it last. There we go. All right, we need a breadboard power supply, very likely. Here is one. Out 1 and ground, yeah. So it goes this way. There she blows. These are going to get mighty hot, so I better use the USB. But this is a stupid USB. It's the micro. Not micro, sorry, mini. And I had a mini USB somewhere around here. My kingdom for a little bit of organization. Oh, here it is. Okay. Plug this bad boy in there. Oh, it's full of dust. Dusty old bones. Okay. Now we need to jump power to here. I need a male to female. I need 2 male to female, in fact. Hey, you know the song. Nice. Sum 41, my childhood. Okay. So, VCC is purpley for the Swedish people in here. Red is ground. I mean, white is ground. Turn that one off. So now, essentially, all we need to do is put power onto the middle pins there, and then we should be good. Probably should find some colors that are representative. You need to edit your wish list. Me? I mean, I have other priorities at the moment. I'm not worried about anybody buying anything on my wish list anyways. The Patreon has been dwindling, and I understand because I don't produce videos. So right now, very low priority. Okay, so ground is the top of the two, so I'm going to put ground last. I need to get back to making videos first and foremost, and then we'll see about editing wish lists. All right, so technically, that is not working. So in 1 and 2 down there, and out 1 and 2 should be here. VCC is the third pin, 1, 2, 3. Ground is the fourth, that's this one. If I pull them high and low, no. Both low, both high. Okay, let's think here for a second. So in 1, that's this one. In 2, that's that one. VCC and ground. The only thing is maybe the grounds aren't linked across the, because this should be outputting to both, but I'll just make sure the grounds are linked. So let's try now. Nothing. Maybe, hold on. No, still not. Okay. So that's a no. Okay, VCC ground. It's at 5 volts. I can check the voltage on here. What was that chart saying? Yeah, if both are 1. Oh, one has to be high, one has to be low. I see. Okay, still not working. All right, let's check power to my board. It's got 5 volts. Let's check. That's 5 volts. That's 5 volts. Okay. That's good. No. How it works is constant on will make it turn constantly, and then you PWM one of the two to get a PWM speed. Okay, so it's outputting nothing. There is no voltage on the output. Okay, let's ground this. Check here. There's 5 volts going there. And that's pulled low at the moment. So that should work. Yeah, there's literally no output. So I'm just going to confirm that there is a high on the second pin. Yeah, 4.6. And let's confirm that there is definitely 5 volts making it to the board. Yep, definitely 5 volts making it to the board. Okay. Those are in the proper holes, 1 and 2. Feels like that LED is quite dim on there. What do? What do indeed? And the issue, like, what happened? Okay, what happens if we just straight up give the motor 5 volts in ground? Does it work on 5 volts? Let's start there. Like, who knows? Maybe it went over current. Right? Maybe the overcurrent protection is working right now. Nope, that works. Okay, let's try the other channel. Maybe we have a bad channel. So let's plug this in. Okay, we're going to flip this to the other side. Everything seems so simple on paper. Nothing. Literally nothing coming out of there. 0 volts. Oh, I shorted something. Ooh. Something is smelling. Is PCB labeled correctly? Well, the tutorial had the same labels. Oh, there's no battery in here. What an idiot. Come on, buddy. Don't be like that. There we go. It's turning on. You need tea. It's a smoke 'em if you got 'em situation, since I've got a thermal camera. Okay, yeah, it's my power supply got a little smoky when I shorted a pin, I think. Okay, so we know we're getting 5 volts there. Like, that's the thing, I've got 5 volts in ground. Everything is proper. Oh. Oh. Oh, I'm an idiot. Disregard. Disregard. I had the board upside down. Okay, so it's the polarity was reversed. Well, it's a pretty freaking good board if it does have reverse polarity protection. Okay, so now I'm in I'm on the output side now. Hang on. Something is... Yeah, so now I'm on the wrong side. Okay, so if I flip it like this, then... Yeah. Hang on. So it'll be VCC ground. Okay, so ground, VCC. So input, input, and in 1, 2. My brain is broken, folks. Okay. So this should work now. Well, it's much easier when you do things right, isn't it? So this is how you PWM it. So essentially, you have it running, right? And then you go like this. So that's how you PWM. So this one's floating. So if I pull both of these down, so that's stopped. So yeah. And then, so it's turning this way right now, right? Yeah, turning clockwise. If I flip this, yeah, now it's counterclockwise. Keep touching the backing with that. So I don't know how fast. This thing is probably going to get hot if I stall it. So essentially, yeah, you can run 2 of these motors on one board. Quite a bit of torque. Ow. Yeah, I can't stop that with my fingers. Little motor has some go. So let's stall this and see how hot it gets. So you can drive 2 of these motors with this board. So I'm essentially going to hold it here, and I'll see how much our circuit heats up. So really the only hot thing right now is my breadboard thing. It's like there's the motor driver, and it is cool. Oh, there, I'm starting to heat it up. Ow, 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 that freaking heat my finger. There, you can see the hot spot. So yeah, that's staying cool. It's like 26. Trying to stall it, but it just isn't working. Yeah, I feel like my power supply will give up first. That shouldn't be active, you know, because it's USB. So that shouldn't be getting hot, but it's like 50 degrees. The only thing I don't like this thing. I need to redesign this eventually. So yeah, both low, it won't go. Both high, it won't go. Look at that, it jumped. So this should actually be locked now. Yeah, so it's got the brakes on. And then that goes the other way. Pretty neat little board. Now we can do an Arduino sketch to run up each. Like maybe we can have 4. We'll do 4 PWMs. I would like to make a series of these input boards. See, this is how I get derailed. I don't really want to do the work that I set out to do. I want to do different work. Because I'd love, yeah, a different kind of input board. Maybe only have 2 channels, but way more of them, and then put them all together. This is my problem, though. I'm always like that. Because see, look, all these components. I want to make SMD. Don't mind me, guys. I'm absolutely nuts. I want everything. I actually designed this when I didn't have a 3D printer. So now I can do this in a 3D printer. All right, so that works. So all we need really is 4. So per motor, we need 4 channels. I can see how that's problematic. But if you only needed forward, you tie 1 to ground. Yeah. And then you can just activate like this. But I mean, who wants forward? This is H-bridge for a reason. So you'd probably want it, you know, to do your reverse too. Just having a think. This is bothering me. It shouldn't be, but it is bothering me. Oh wow, I built this in 2021. Look at that. Simple Electronics 2021. Might be time for a revisit. I think I'd like some more ka-clunky switches. Anyways, that's neither here nor there. So essentially, if I'm building a Arduino sketch for this, let's see. Screen. Oh, hold on a sec. Don't really have a safe Discord place to go. Whatever. All right, so screen. I'll send you back there for a second. And here we go. Okay. So, setting up pins. Oh, here, let me. Pins for the DRV8833 board to use as inputs. This is a simple sketch to allow you to get up and running. Cool. God damn it, every time it does this. Up and running quickly with DRV 8833 breakout board. To support my work, check out my YouTube channel, https://www.youtube.com/simple electronics, or buy your DRV 8833 using my affiliate link here. AliExpress, DRV 8833. Text copy. There we go. All right. And then we'll go here. Uno pin map. Just need to know which ones are PWM capable. Here. Tab. All right, so 11, 10, 9, 6, 5, and 3. So I can see the issue here that since there's only there's only 6 PWMs. Huh. That's not quite enough PWM pins. So this one, they're all PWM, but you can't use all of them. That is problematic. So on the Mega, 8, 9, 10, 11, 12. You've got 12 PWM pins. So that's interesting. Oh, these guys. This is what I was looking for. The Uno has only enough pins for 1.5 boards. Oops. So let's say you want to control like 5 motors, you need 10 PWM pins. Oh no, Cora. I hate Cora. I don't, whatever. Oh, this is AI. Well, so for the excavator, I don't know, it's a lot. Pi Pico pin diagram. I don't know which one are PWM capable. Okay. I don't understand what this means. There seems to be a lot of PWM, but why does this say PWM 0A, PWM 0B, and that's PWM... I'm confused. So the original uses a ESP32 with expander. This guy, MCP23017. This guy. So I have the 23017. I don't know what that. I don't know if you can PWM every. I don't know what any of this means. That's I squared C. SPI input timing. Okay. Yeah, me neither. That's okay. No worries. So looks like so we've got an output pin. And then you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 output pins. Now, the only thing is I don't know if they're PWM. Are all of the MCP 23017 17 output pins capable PWM? On, off, or pulse stuff. Okay. This is not quite what we were looking for. Freaking Adafruit's got everything. Oh no, it's okay on their thing. This is not helpful. Okay. Okay, so it seems like you cannot. I have to do some research on the MCP 2317. Oh, look, literally that question that I need. Hardware PWM. Huh. Bit more expensive, okay. This looks like a whole bunch of jargon here. Let's see what they said. Servo driver. They do have PWM. I may have one of these. I think I bought a multiple servo driver. So I will say it might be really useful to have a shit ton of PWMs. So let's see if these are... Yeah, I have one of these boards. 100%. Do I need all the supporting components though? Like the I2C address. Okay, let's... So, yeah, I don't know. This not quite what I'm looking for, though. Because the breakout board, like, for me, it would be just the... It would be just the module. Let's see. Is that what I typed? 9685. Okay. They're LED drivers. That's interesting. They use LED drivers. Nine six eight five. Is that what I typed? Yeah, 9685. Okay, so address 12 LED pins. No, 16 LED pins. Okay, so I don't know what's going on here, but there should be a library for this, right? There we go, there is a library. There's a couple libraries. Okay, so that's good. Oh, look at this nutty stuff. Wait, how many pins do you need to run this? Maybe that's not D, maybe this is just the digital signal. Yeah, so someone went through this, programmed all the stuff in. God, I wish I understood all this stuff. Look at how precise the timing needs to be. Is there like a default circuit? Does it need any... There's not even like a default circuit diagram. Oh, here we go. So LED 0 is running one LED. LED 1 also running one LED. LED 2 is running 3 LEDs. LED 3 is running... That's interesting. So they're showing a bunch of situations here. Same thing here. That's crazy. You have 16 channels. This is crazy stuff, man. I might order some. They seem to only come in these boards. Oh, here. Yikes. $30 for 10 of them. They're $3 a piece. Kind of expensive. I was hoping to do it with stuff I had here already. These boards are not it. MCP 2317. Let's see what that says. MCP 23017. Oops, 23. I'm just trying to figure out if the MCP 23017s I have ordered can do PWM, but I'm shite at reading diagrams and stuff, or data sheets. Because I have these, mind you, I have the SMD version, but how do I know if I can PWM? It has 16 I/O, that's good. But can they do PWM? And how are you, Peter? So I have these guys. Anyways, I guess this is besides the point. For the demo, I just need to run one, so I can do this after. All right. I got distracted on a side quest. It's going to be lunchtime very soon, so kind of makes sense. ESP32, Arduino Uno. Bitbang PWM, but hardware assisted, no idea. Yeah, so me neither. I'm not really knowledgeable in these things, right? So, all right. So 11, 10, 9. It's weird they don't have that many close together. So 11, 10, 9, and 6. 11, 10, 9, 6, then 5, and 3. Three are PWM capable on Uno. Put that there. Okay. Const. Is it like this? Const int? No, const int. Const int. Damn it. Arduino reference. Functions, variables. Where? Int. What about the constant int? What's the unsigned? Oh, const. Okay, const space int. Okay. Int. In 1 equals 11. In 2 equals 10. Const int in 3 equals 9. And const int in 4 equals 6. The 4 in pins for the DRV 8833 in 1 and 2, 1 and in 2 control 1 motor. In 3 and in 4 control another. Okay, so that's good. Setting pin mode to outputs. Pin mode. I don't remember the syntax. Scope and something. Oh, variable scope and qualifiers. Yeah, there we go. All right. Pin mode. Never remember the syntax. Okay, pin and then mode. In 1. Output. And 2, 3, and 4. Maybe I shouldn't call them in. Four. How's it going, Shara, Princess of Powers? I am just doing a tutorial on how to use the DRV 8833, essentially. So, yeah, that. All right, so basically, maybe I shouldn't do that. Maybe I should read my emails before deleting them. All right, so that is that. So that's already done. What else do we need to do? That's it. So if a pin is output, probably want to pull them low, right? Right, so go digital right. Should be. Yeah, whatever. Digital right is good. Sig 1, low. Two, 3, 4. Oh, hold on a sec. Send you over there. Oh, Discord notification. Not super important. Back to screen. All right, so here's where you would put your control stuff, but just for an example, I don't know if I want to write my own function. Well, anyways, let's go make motor A turn clockwise. Welcome back, Franco. Turn clockwise, that would be analog. Okay, we're going to do a digital right. Right, sig. Oops, sig 1. High. Digital right. Sig 2, low. Delay 1000. And then stop motor A. Go digital right. Sig 1, low. Digital right. SIG2 low. This is exciting. Well, I'm glad you find it exciting. Make motor A turn counter clockwise, digital right, SIG1 low, digital right, SIG2 high, delay 1000, stop motor A, just do this, low low, make motor B turn clockwise, and then we just need all this. We'll just take all this and just copy it, and then we'll just, it's B, that's, and then we go SIG 3 and 4, B 3 and 4, and 4, B 3, oops, 3 and 4. Maybe I should put a delay here too. Delay 1000. Put that everywhere after the stops. Okay, so this is shit code. Yeah, the thing is, my channel is facing very much beginners, and the goal is not to write good code. It's to write, like, for them to understand what's going on. I agree though, if I wasn't making a tutorial video, I would you know, probably write it a little bit more like that. Elias, this is symbol chat. Don't know how to use that. I'm not sure what's going on there. Set of motor rotations are DRV. This is good for hand winded copper motors. I am not sure if I understand what you're saying. Tools, board, Arduino, Uno. So let me grab an Uno, and we're going to program this. I should have enough done by the end of stream that I should be able to film this, probably off stream, but after lunch. Do I have an Uno kicking around? I might end up just ordering a whole bunch of Unos because I'm always looking for them. They're like the easiest thing to program. Let's go back to webcam here. There's an Uno. It's got this stupid printer connector though. I should just order a whole bunch of Unos. Franco, when you get a moment, can you add to my order list to get some more Unos, please? Okay, now I need a USB with the printer cable. Where the hell would I find a printer cable USB? Good question. This just can't be the most entertaining, looking for a USB cable off camera. Brush motor and brushless motor winding and time control on it. DC. I don't. I'm sorry, Shara. I'm trying. I don't really understand what you're getting at. This is for DC motors. Yep. So we got that part. Definitely. And it may be me, not you, that's confused because I didn't sleep well. Well, this is frustrating enough that I am going to just order some Unos. Thank you, Franco. Over here. Uno, 5 pieces. $30 for 5. Pause time, so it's 1 second. It's just for a demo. So that's $6 each. Actually, I don't even want these because they have the printer port. Give me one with type C. Oh, these have micro. That's better. So this one has micro, it has wireless too. I don't need that. So that has micro. So that's cool, but I want C if possible. No, okay. I will deal with micro. The chip is almost self-contained. Which chip? So the one with micro is, they're $5 each. So if I get 5, that's $25. Just gonna go ahead and cart. Check out. Might as well do my shopping now. Let me see. Oh, where is I'm gonna bring you there. Let me see if I have another one. If not, I'll just go looking in my USB bin. Surprised the cost of boards. The IC is very expensive as well. The 328p is used in so many things that there's like constant demand for them. Okay. Here's one. I don't know if this is going to be any good. But let's see. Oh. All right, just texting my mom there. Let me check my cart. Try 18 more coupons. Yeah, go do that. What was I saying? Oh yeah, if I go back to here, let's go. What is it? 18 mega. 328p. So just the individual chip. Hang on, gotta check this on my end here. It's $4 for the chip, because see, it's $2 plus $2 shipping. And you can only have one, so that's a special price. So here, just about $4. So yeah, you want 3, it goes, shipping goes up. So essentially, it's not much better. Oh, I don't want a dip chip. The dip chips will be more expensive. See? So this one, see, that's a welcome deal. So that's not for real. I'll tell you the full price. It's because I'm not logged into that browser. So it's $4.22 for this. So it's the same price as the whole board. So as you can see, the chips are so expensive anyways that there's no point. You just buy the boards. Probably if I wanted the chip, I would just desolder it from yeah, see that you can't even. I'll just desolder it. RP2040 is possible, but also very expensive. Again, demand is high. 2040. Oops. I don't know if you can find even just the chip. There we go. So it's about $2 a... Oh, yeah. It's about $4 a chip. Same thing. Although it's way more powerful than the 18 mega 328p, for sure. So, yeah, this would be much harder to solder as well. But, like the board, but again, here's the board. So the board is almost the same price, so why not just get the board? You know what I mean? Because then you have the USB connector, you've got the support components, everything on it. So it's kind of a tough call. All right, what was I doing? Oh yeah, I was gonna confirm your order. Continue to check out. I'll send you guys to the webcam just in case. PayPal. Oh, this is gonna go to my credit card because I have no money in PayPal. Great. Okay, stuff is ordered. I was hoping not to order stuff, but there we go. Order stuff anyways. Okay, back to the screen. We're gonna try to program. Okay, import. We'll see if this Arduino programs. Okay, it's plugged in. Tools. Oh, COM3. Okay, upload. Oh, I have to. What am I calling it? DRV8833. Try. Yeah, you could damage the chip while soldering it too. But I think the biggest thing for me is that I don't want... Oh. 4... Pin mode? Did I not read pin mode? This doesn't make any sense. Oh, maybe it needs to be in the setup. Let's try that. What do you use for desoldering the chip? The size standards for each chip varied. Are there tools? Yeah, I use just a desoldering hot air gun. Very inexpensive. What country are you in, Shara? No, they're made to be soldered, so they do have some heat resistance. Yeah, if you go too excessive, you're gonna melt the shit out of it, but it's really not that bad. All right, so that seems to have programmed. Let's go back over here. All right, so we should be able to just take these off. Take these off too, don't need these. Okay, and then let's go pin 11 and 10. What's going on here? Oh. Oh, these are floating. I see. Okay, pin 11 and 10. And now we just need to pop the power to the board here. And it should run our demo sketch. Just need male to male for the power. Don't need this. So here's the ground. Can use this for ground. For RP2040, the programming adapter QNF56 to dip is like 100 plus. Interesting. I mean, that makes sense. Okay, and yeah, one more. I need a male-to-male pin. And then it should do a little demo dance. We won't see all of it because we're not plugged into all of it. I really should have populated the male pins on there, but I did not. So that's what I get. Where the heck? Oh, breadboarding. That into 5 volts. So there we go. So it's going to go counterclockwise, then clockwise. I just need to change the input direction. So there. Clockwise, counterclockwise. How's it going, MT? So it seems like it works. So yeah, so the only thing you would need to do is PWM one of the pins in order to go slower or faster. So let's try to code it a bit more intricately, because there's about half an hour before I finish the stream. So let's see if I can code this a little more nicely, and then we can call it a day. All right, so. All right, so let's make our own functions. I think I just void motor A, CW, and like this. So we'll steal that. X, then motor A, what did I do? Underscore CW, CW, I'm new to writing functions, so please don't judge me. Let's go. Void stop all motors. Kapton tape and RP2040 and QNF56. Use stuff to explore. I'm from Malaysia. Okay. I'm in Canada. Okay, to stop all motors. X. Okay, and then motor B or motor A. Let's go over CCW counterclockwise. Control V. There we go. And then B 3 and 4, B 3 and 4. So now I should be able to make them all. So if I go motor A underscore CW, and then delay 1000, and then stop all motors, and then delay 1000, and then motor A CCW, and then stop all motors with a delay. Oops, need a delay first. Essentially this. And then motor B, CW. Then motor B, CCW, whoops. And then should be, okay, so in principle, this should work exactly the same. 38.33C, holy crap, that's hot. Okay, so in principle, this should work exactly the same. We should just be able to upload this. I'm going to verify this. Should be able to upload this and it should work. Oh, motor ACW was not declared in this scope. Do I need that to return a void? Let's try that. Does that work? Software programming compared to electronic engineering can be made with same flowchart. Oh, oops. Missed a semicolon. Okay, so it should work with my new functions. Done uploading. Okay, back to screen. When it got too hot to fish, I knew it was going to be a miserable day. Yeah. Might go fishing this evening, but it's raining today, so. 10. So this should act exactly the same now. Let's ground 5 volts. It's exactly the same now. Looks good. Shara, do you have a YouTube channel? Or your name is just your name? So now all we need is one more motor to display the other channel and a couple more lengths of whatever. And then we're good to go. So let's get some wire, some of this stuff. It is 11:40 p.m. here. A.m., sorry. 11:40 a.m. Not in Australia. Okay, turn on. Let me know if the noise gets too annoying for you guys. Oh. We had shorted something. I had some pin headers. Oh, here they are. Oh boy, my stomach just made a loud groan. It's gonna be time for food very shortly. Opening the entire architecture and fixing it back for a large project doesn't seem suitable for immediate. Plugged out the earphones. Shara, are you using Google Translate or ChatGPT or something? You're sounding very much like a robot. Unless I'm really misunderstanding you. Android phone battery running low. Glad the motors work well. Nice to meet all of you. Yeah. Thanks for stopping by. Okay, now we need two more. That would be male to male. Oh boy. Need breadboarding. Oh man, my stomach is making crazy noises. There's one male to male, male to female. Looking for a different color. Another male to male. There we go. 9. Pin 6. There we go. That's hilarious how they jump around like that. Okay, so like 10 minutes before stream is done, I'm gonna see if I can update this to PWM. All right, so let's see. Screen. Okay. Motor A. CW. Half. Okay. And then like that. Stop all motors, and then motor A, CCW half, and then stop all motors, and then motor B, CW half, and then stop all motors, and then motor B, CCW half. Oops. Okay, now I just need to write void. Actually, I'm going to write it up here. Void motor A, CW half. Open this, and then for CW it was high, so digital write, no, analog write. Sig 1. How does analog write work again? Functions, analog write. That is then 0 to 255. Where'd my calculator go? Okay. So like 127. 127. Digital write. Sig 2. Low. Then void motor B. No, motor A. Clockwise. Half. Open bracket. Open bracket. I want really a space there. I'll deal with the formatting after. Digital write. Sig 1. Low. Oops, that's CCW. Analog write. Sig
Sig 2, 127. That should be right. Okay. Then motor B. I mean, I'm sure I'm doing this wrong, but that's okay. Void motor B, CW half, I could be mistaken, but I feel like she's using Google Translate. So maybe that's why it's very robotic. Analog right, Sig 3, 127. Digital right. But you have full moderator powers, so if you don't trust it, you go ahead and follow your gut. Void motor B, CCW half, and log right, no, digital right. Sig 3 low, analog right, Sig 4 127. So let's verify this. I'll go grab the Arduino while we do that. Could be speech to text, yeah, could be. Hey, done compiling. I can't believe that. Here, let's upload. So, in principle, oh shit, no, I need to delay this and stop all motors. I forgot this part. So in principle, now it should do the same thing, but it should cycle between full speed and half speed. And I think that's plenty enough for a YouTube tutorial. Like, people can figure out the rest on their own. Webcam. Okay, so let's try to get the order here. Gray will be in 6. Gray's in 6. Orange. Yeah. Orange is in 9. Green will be in 10. White will be in 11. Ground in ground. And power in power. Talking to the boss if they're pleasant enough. Political pushy ones. Yeah, fair enough. Okay. Clockwise, counterclockwise. Then should be clockwise, counterclockwise. And then half speed. There we go. And this one half speed. So there we go. It works. Can't believe I did it. So I just need to do like documentation. But yeah, essentially, this will work just fine. So that's the plan for the rest of the day, is to work on that. And I mean, what else could you want for a tutorial? It shows you how to do full speed both directions on 2 motors and half speed, which means you could just replace the number with whatever you want for whatever speed. So right in the nick of time, it is 11:57 a.m. So it's going to be time for me to get some lunch. It's got a good beat to it. Yeah, not bad. So I'm going to go grab some lunch. I want to thank you all for being here today. Expect a video, like I should be filming this video today. We will see about editing and stuff. But yeah, thanks for being here, everyone. I'll catch you on the next stream. It might be tomorrow morning. We will see. I may decide to go fishing tomorrow. We'll see. Have a good day, everyone.